Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I am Dr. Elena Hyde, and I'm joined tonight by two other fabulous hosts. Satish, want to say hi?
Yes, hi everyone, and thanks for the fabulous title. Not true.
It's wonderful to have you here tonight, and we are, of course, joined by the fabulous Paul Delaney.
Good evening, one and all.
And we are all three of us broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is, in fact, Astronomy Night in Canada, if you didn't know. The lineup is all Canadian, starting with ourselves, York Universe, and then on to Western Worlds, Quirks and Quarks, and Science for the People. Just in case you might have not heard this program before, York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning if you're around 2 a.m. if you're interested in Universal Time. So the York Universe production works in concert with our online public viewing program run by the Observatory team, which is running at this exact same time. So right now you can tune in, go to observatory.info.yorku.ca and follow the links to OPV or online public viewing, join the live chat, and see some amazing images. Our broadcast is powered by and in partnership with astronomy.fm, the voice of astronomy. If you have any questions or comments for past shows, or you have suggestions or ideas, send us an email at observe@yorku.ca. So that being the grand intro for today, I will have to tell you all, on online public viewing, we are just clouded out. So we're showing some beautiful, lovely background images from previous clear nights where it wasn't cloudy or snowing. So we're having a bit of a snow explosion here in Toronto, and it's been an interesting time of the year. And just in case anybody didn't know, I thought I would actually start off this teletube by wishing everyone a happy Chinese New Year. So those of us who are interested in astronomy are naturally interested in calendars a little bit. A lot of calendars use different astronomical alignments, and the Chinese New Year actually goes off of a really interesting lunar calendar. So if you want to read a bit more about that, I highly recommend it. And even if you don't, I want to wish you all a very happy New Year of the Tiger, I believe. So it really is fun stuff.
Yep, Year of the Tiger. Big improvement over the Year of the Rat or the Year of the Rabbit. I like the Tiger. That's cool.
Who doesn't like a kitty? It's a big kitty. Who wouldn't love it? It's
sure.
Lunar New Year, Year of the Tiger. It feels lucky to me. It's 2022, and of course, in 2 days we'll also have 2/2/2022. So it just seems incredibly lucky in many respects. So the New Year on the Chinese calendar, just in case anybody is wondering, is a what's called a lunar calendar, which is a little bit different than a solar calendar. So if you want to find out more about that, there's a really fun article on thetimeanddate.com, which I recommend. They have a lot of really fun astronomy calendar articles.
They have a lot of good information. In fact, that site has really developed over the last few years to be one of my go-to sites whenever I'm trying to figure out, when is the new moon, what is the distance to the moon, what is the lunar eclipse happening, et cetera, et cetera, et cetera. They've got a lot of good info.
Oh, yeah. If you're looking for a good moon altitude calculation per date, absolutely. And as much as I love our website, I have to say they're doing it better over there.
Well, for that particular piece of information, that's for sure. Hey, they've got a whole battery of people who are hired for the occasion, dedicated to just looking after the website. Don't feel bad.
Exactly. I don't believe we have that just yet. So,
not unless you're keeping it a big secret.
Surprise. No, it's just you and me, Paul. All right. Well, speaking of various other things and calendars, we're going to be doing a little bit of time traveling tonight because, Absolutely. Of course, we have a set of this weekend space astronomy history to go through. So as you know, I always like to say that telescopes are a bit of time machines, but for this particular part of time travel, we don't even need telescopes. We just need a little bit of research and a little bit of sort of spinning the date. So I'm going to round off our discussion of time and dates and pass it over to Paul. I believe you're taking us back in the time machine to 1958.
to just about the beginning of the space age. Just to remind everybody, October 4, 1957 saw the launch of Sputnik 1. That was the first artificial satellite to be launched into Earth orbit by the Soviet Union. Well, needless to say, the United States had their noses out of joint with that launch. They felt that they were going to be the first of the major nations on the planet to launch an artificial satellite, and they were working quietly and slowly towards it, but then they were a touch surprised when Sputnik 1 made it to orbit. And barely a month later, Sputnik 2 made it to orbit, putting their noses even further out of joint. The U.S. response, and remember, NASA did not exist at this point in time, but the U.S. response occurred on January 31st, 1958, with the launch of Explorer 1. Explorer 1 made it successfully to orbit. It was a really low-mass spacecraft by comparison with Sputnik. Sputnik was about 84 kilograms. Explorer 1 was all of 14 kilograms, really just sort of like a really pregnant basketball. I mean, it just wasn't very massive at all. But it was a long, thin, slender, it looked like a nice little rocket, and it contained 4 science instruments. So unlike Sputnik 1, which really just contained a transmitter that went beep, beep, and beep, and it showed the Soviets' capability to put an artificial satellite into orbit, there was no real science that was to be gained from that particular satellite, other than, as I said, that they were able to do it, which was pretty good. But Explorer 1, by contrast, was actually a science payload. And the principal investigator of those science payloads was a guy by the name of James Van Allen. Well, they got Explorer 1 up into orbit on January 31st, 1958. It delivered 60 watts of power to those instruments. So, it was really a lightweight vehicle in many ways. But the science return over the ensuing 4 months was really quite amazing. It operated for 4 months. It stayed in orbit, actually, for 12 years. It didn't deorbit until March 31st of 1970, so it was up for quite a long time. But its active lifetime was only 4 months. While it was in orbit, the principal instrument was basically a cosmic ray detector, and it measured the radiation environment that the spacecraft, Explorer 1, was passing through. Now, this was a highly elliptical orbit. Unlike most satellites in low Earth orbit, they are fairly circular. Not exactly circular, but pretty close. So their apogee and perigee is their furthest point from the surface of the Earth, and their closest point were, within a few tens of kilometers of each other. By contrast, however, the Explorer 1 orbit had a really elongated orbit, and it went out to well over 2,500 kilometers for its apogee, and perigee was only a few hundred kilometers. So it was perigee in low Earth orbit, but the apogee was much higher. As a consequence, almost from the outset, they had a perplexing problem. The cosmic ray detector was going nuts in low Earth orbit and was going dead silent at the higher points, at apogee. And of course, everybody's going, oh my gosh, the instrument's faulty. But it kept doing this, and all of their reliability checks suggested that the spacecraft was behaving just fine. It eventually dawned on them that they were detecting distinct layers surrounding the Earth of high-intensity radiation. And in fact, after they had figured this out over the ensuing 4 months, the Van Allen radiation belts, so dubbed, came into existence. These regions above the Earth of compacted regions of high radiation activity. When you get above it, of course, your radiation count drops to 0. So the legacy, if you will, of Explorer 1, the first US satellite to make it into orbit, the first artificial satellite to make it into Earth orbit, was the recognition, the realization of the Van Allen radiation belts. And to this day, of course, we continue to monitor them. They are rather important as far as radio communications are concerned. They are protective of us as far as incoming radiation is concerned, and so on and so forth. So they were discovered in the early months of 1958, following the successful launch of Explorer 1 on January 31, 1958.
Wonderful. And I have to say, it is a much more scientifically, I suppose, abundant mission than the old Sputniks. But I will say, when in defense of the Sputniks, it might have just been beep beep beep, but it really was the beep heard around the world, right?
Oh, it
Because
was. Absolutely, no question. And I'm certainly not belittling the effort of getting Sputnik 1 up. It was phenomenal to think that, up until that point, nobody anywhere had the capability of lifting an artificial satellite into orbit. So rest assured, Sputnik 1, the beginning of the space age, full credit to the Soviet Union for being able to manufacture the engineering to actually do it. And, a month later, to not quite such a good story, to be able to launch Sputnik 2 and the first living creature into space, Laika the dog. We won't go through that one, though, because that one's a sad story, too. But to be able to actually launch the era of science in space, and let's face it, science in space is phenomenal, that was left to the US in January of 58.
Yeah, and it is interesting, how these things end up, sort of evolving over time, and the radio signals, especially this, initial sort of beep signal of Sputnik having such a large impression. I've always thought it was, probably very influential in our later on sort of debates about whether or not some of these pulsar signals might be artificial, because of course, what are pulsars doing than beep beep beeping at us?
That's true.
And wouldn't it be nice? And it sort of gets that science fiction crossover. And of course, having the real science behind there is of course very important as well.
Absolutely.
Okay. Well, let's spin our time machine again, shall we? And let's go ahead and go all the way up to 1966. Satish, I believe you have a little bit of a different mission to talk about.
Well, actually, I'll just be bringing the attention back to Soviet glory, or like the Soviet space mission glory. So, and I think then you would be able to add a lot of story to it. So February 3rd, 1966, that's the date. And Luna 9, I'm not sure why they named it 9. I'm sorry, I'm fumbling. It was an uncrewed spacecraft which weighed 99 kilograms to be precise. It was launched by the erstwhile Soviet Union, was able to successfully make a proper landing, survived to actually reach the lunar surface. And this was the first of its kind again in human history. Not just on the moon, but on any celestial body. The launch vehicle, also known as the Molniya M, was derived from the R-7 Samyorka intercontinental ballistic missile. Pay attention to the details. So perhaps marking the beginning of a new era in using missile technology in the right manner. Although I wonder if this had anything to do with the Star Wars program starting or dissolving later. But anyways, the astronomy still is the payload was first placed in a low Earth orbit inclined at 51.8 degrees at an altitude of 168 by 219 kilometer. And then it was the fourth stage boost that raised it to a height of 500,000 kilometers of altitude. So you can imagine, do the math, visualize. This was followed by a deployment in a highly elliptical geocentric orbit. And obviously from there on, it was a cakewalk. The craft simply employed nitrogen jets to achieve a 0.67 RPM spin. If you're really visualizing what I'm talking about, try doing that to a coin and let me know if you succeed. And then on the day of the landing, the jets whizzed again for like 48 seconds, tiny time frame, course correcting and jettisoning the craft to a speed of 71.2 meters per second. Again, keep doing the math. It's a good exercise to try an imperial conversion of this number as well. And it landed at a site known as the Oceanus Procellarum.
Oceanus Procellarum.
What?
Yeah.
See? Exactly. Anyways, I wouldn't repeat that. That just means ocean of storms, which is what I'm doing right now, creating storms. And then the 9 pictures that it did take were the object of a lot of drama, which I will not get into, but maybe one of the professors can actually take us on that journey as well. It was wonderful.
A journey of drama. I think we can do that, Paul.
Jodrell Bank enters the picture at this moment in time because, of course, the Soviet Union is transmitting these 9 images back to Earth, and the plan was to unveil them in a moment of glory, the Soviet Union doing another space first and so on, except that the signals were intercepted by Jodrell Bank Observatory in England, and they realized quite quickly that the way the signal was encrypted was a standard that was used around the world for basically facsimile transmission. And so, of course, one of the local newspapers there said, great, and they interpreted all of the data, and they published those images of Luna 9 sitting on the moon surface, panoramic views of the lunar surface, the first of their kind, and it was published in England before it actually was published in the Soviet Union. Yeah, I think that's really quite cute, but nonetheless, the bottom line to it is the images were made available eventually everywhere, but they were first released by the Brits.
Well, there's being scooped, and then there's being scooped. Like, this is a whole nother level of scooping there. Presumably there was some sort of credit included in the article.
I hope so.
Yeah. Oh dear.
Another piece of trivia for you. As Satish indicated, this was the first successful soft landing on the moon surface, in fact, of any body in our solar system. But for the record, there were, prior to that successful landing, 10 crash landings on the moon, some of which were deliberate, others not quite so deliberate, 5 from the Soviet Union and 5 from NASA.
Wow, they keep a score? I mean, and they actually match the score.
It was the height of the space race, mate. Yeah, everything counted for or against.
If I may add, the scoop probably was a giant leap for mankind. That was the first giant leap for mankind.
Oh, it was a big deal. There was no question. No question.
Well, and showing that it can be done is really, really changes things in a lot of ways for a lot of people. And it's interesting as well because you emphasize the getting into orbit again with this mission, because this was still 1966. This was really, really hard. And getting into orbit, we've all now seen, we're in the year 2022. Can you believe it? We've seen so many different companies going into space just now in 2022, but it's still really, really hard. Getting off of Earth's surface is it's a drag, right? So it is one of the things that remains a big barrier to massive amounts of space exploration. And one of the things that was proposed fairly early on that I always like to come back to is, gosh, wouldn't it be so cool if we could find some way to make a space elevator work? Because that would make this all so much easier. Of course, in the 60s, this wasn't possible, and even now, we don't have anything that can be a proper counterweight, unfortunately.
No, not at
all. That reminds me of the story of the emperor from somewhere in the Middle East in the ancient times who wanted to build a tower right up to the heavens. I mean, when you talk about space elevator.
He was ahead of his time.
That's visionary.
Yeah.
Because that is, I mean, if you could do it, if you could build it even just once, everything else would become so much easier. Your missions would all become so much more feasible. You'd be able to launch big things. You could build stuff in orbit. You'd really just open up the whole solar system. If only.
The cost to orbit would be much, much lower. That's for sure.
Yeah.
I mean, yeah. One last thing, just before we move on to your note there, Elena. One of the things that Luna 9 also successfully did by transmitting those images back is it showed that this vehicle wasn't sinking into the lunar sand. There was still a bit of a prevailing back thought. No scientists really believe this, but they were worried that the surface of the moon might have been sufficiently thick with dust that as you landed on it, you would sink, perhaps not, tens of meters, but even if you differentially sank several centimeters on one side, that would preclude successful operation of the vehicle, and of course, with humans going to the moon, being able to get off the lunar surface. Luna 9 verified that the surface of the moon really was quite solid, and once you landed on it, you were not precariously sinking in some strange manner.
Yeah, exactly. I mean, we didn't really know what kind of surface it would be. I mean, you could tell it has a certain albedo, but what else do you know without being able to touch it?
That's right, exactly. Crashing in doesn't exactly tell you whether or not you will or will not sink with a soft landing. So Luna 9 was really important in that regard.
Yeah, it reminds me nothing so much as like, well, how do you know? Because I mean, we've all seen this big fluffy snow in Toronto. If you jump into a pile of that, you're just gone. And my little kitten tried it the other day. She had her leash on, jumped straight into a snowdrift, and you just couldn't see her at all anymore. So it's if that's what you're looking at, that would be a terrible place to land.
Exactly.
All right. But yes, moon stuff, very fun. So I think it's about time that I move us around a little bit more. And I'm actually going to go way earlier. So we're going to take a little bit of a shift and go from 1966 back to the 1800s, all the way back to 1791. So this is a big shift in time, but for a very good reason. In 1791, there was actually a really interesting thing happening. And we like to talk about, history of, North America and how things evolve. And in 1791, George Washington, who was in charge of things down south, he actually was interested in trying to survey a new federal district, which later became known as Washington, D.C. He put a fellow named Andrew Ellicott in charge to make this survey, and that's not the really interesting thing that happened, actually. What actually happened is that this survey team found a really unique astronomer who not just led the measurements, but also developed an entirely new astronomical almanac as part of this survey. And this astronomer was Benjamin Banneker, who, since we are quickly approaching, actually tomorrow, Black History Month, I just thought, this would be a wonderful, wonderful chance to talk about somebody who really doesn't necessarily get talked about nearly enough. So Benjamin Banneker was one of the earliest, active astronomers in North America for his modern astronomy. So I'm not talking about, indigenous astronomers, but he was also a Black man in the U.S. And his work here was absolutely amazing. So this was a really interesting time, this 1791, and it was in February, in the beginning of February, which we're now approaching, that he actually got assigned to this survey project. And it was a really interesting astronomical project. In 1791, measurements would often use astronomical sources to determine positions. So in order to make this truly accurate, he had to find a really, really accurate clock. We talked about calendars earlier and all the different calendars that are out there. Well, in 1791, to get an accurate clock for local time, he could measure the maximum altitude of the sun, which would give a local noon. For 0 degrees longitude, he used Greenwich, England. And once the federal district was properly surveyed, the Ellicott's team, the actual team that was behind it, set the 0 degree longitude line to run through the center of the U.S. Capitol building. And later on, in 1884, Greenwich, I'm probably saying that wrong, Greenwich would actually become the international standard for the prime meridian. But originally, it was used by Benjamin Banneker. And I believe that was fairly influential because when he was doing this survey, his almanacs that he created were so good in 1792. So a year later, they became immediate bestsellers. So if you want to look these up, they were published between 1792 and 1797. They have a lot of very, very fancy math, including spherical trigonometry and really quite incredible computations by hand. So if you love math, this is the book for you. It was really quite amazing because this fellow, he was not just a black astronomer in North America. He was, a bit of an engineer. He built mechanical objects. He actually constructed several timepieces entirely out of wood. Famously, he, did not have access to a lot of metals, and the clock that he created apparently became somewhat of a local tourist attraction. And of course, that clock keeping and astronomy sort of go hand in hand. So he taught himself to forecast eclipses, and he actually made corrections to some other astronomers' catalogs who were out at the time. So around the time that this survey was finishing up, just after February, I believe it was April or so, he actually published some calculations showing that another early astronomer, James Ferguson, had actually made a mistake, and his catalogs were about 32 minutes early. So incredibly gifted, creative mathematician, astronomer, engineer, and mostly self-taught at a time when very little, if any, schooling was available to Black people at all in North America. It's thought that he might have been able to attend a Quaker school, but it's totally unknown. So this is one of my sort of favorite astronomy history figures. And in 1791, he was kicking off one of the really most interesting astronomical histories, I would say, of the United States, doing this survey. So anyways, February.
Interesting that he did cite the 0 degree for the prime meridian there, basically in Washington, long before Greenwich laid claim to that particular location. I guess, despite the fact that, he tried to place it there, it didn't take, obviously. The British were still much more interested in claiming the high ground there.
Well, in his catalog, Banneker used Greenwich, England, as 0 degree longitude. It was actually the Ellicott's team who set it to run through the U.S. Capitol building.
Yeah. I'm sorry. Okay.
So he actually did agree with the British in this particular. I'm not sure if it was a political statement or just astronomical artistry, but it was. It is interesting that they did eventually later choose his same location.
Very good. Very good indeed. Well, I must admit, I did not know of this person, so that was really interesting.
Benjamin Banneker, one of my favorite astronomers, and if you're thinking of looking up, we have Black History Month coming up tomorrow, so there actually is a wonderful Black Canadian scientists conference going on right now. We have a few speakers from York. It's on Twitter #, so follow along. I think it's pretty awesome. You will learn all kinds of really interesting stories.
Excellent.
All right.
It says that.
Oh, yeah, go ahead.
I was just saying about Benjamin Banneker. It says there was a biography published in 1972, which is, I think, way too late. Based on actually did so.
Well, and that's he passed away in 1806, and it did take quite a long time for his contributions to be known. One of the advantages that we have with this particular individual are that his almanacs were so good and so popular. So some of his achievements have did survive and became documented, because, as you say, it was something that took far too long to get the proper shout outs, I suppose, which actually takes me to birthday shout outs. So I can get there with one segue. So we do have other interesting things happening throughout all of history. It's not all. It's not all about Benjamin Banneker. I mean, it could be. He could fill the whole episode. But if we are going to move around to some other birthday shout outs, Satish, I'm going to pass over to you. I believe you've got some February 2nd throughout different years.
I actually have, and interestingly, again, referring to Benjamin Banneker's works, he was a clockmaker also, and I would be talking about another clockmaker, of course, like way earlier than him. So first, birthday shout out for Nikolaus Remus Baer. He was born in 1551. He was a German astronomer and mathematician, and practically uneducated till the age of 18, or at least that's what Wikipedia says. So he was discovered and mentored by a famous statesman, Heinrich Rantzau, who is also listed as an astrologer in those days. He initially employed him as a geometer, and I think the word simply means someone who's good at geometry. And that is how he came out with his undiscovered talent. And then he also introduced him to Tycho Brahe, who was an associate of Heinrich Rantzau. Later down the road, he also met Jost Bourget, or Horst Bourget, I don't know how to pronounce that, who was a Swiss clock and astronomical instruments maker. So this is where I was actually trying to connect the clock making thing. But anyways, I think I made a mistake somewhere. He's associated with a mathematical model. Now we're talking about Nikolaus of Prostapherasis, which is basically an interesting name of an algorithm to approximate multiplication and division using trigonometric formulas, a rather effective precursor to logarithmic techniques, which were invented sometime in the 17th century, I think. And while there's loads of history to comb through, what's worth probably mentioning is he also, let me just put it that way, was known as a bitter rival of Tycho Brahe, and he also proposed a heliocentric model, but without the Earth revolving at all around the sun. So in that model, the Earth simply spun on its axis, but it was not revolving. And so happy birthday to him and his efforts and whatever he did and did not do. We also would like to say happy birthday to another person also born on February 2nd, and that was forward in 1786. Jacques-Philippe Marie Binet. He was a French mathematician, which is probably obvious by the name, a physicist and also an astronomer. And to be frank, amongst like a huge list of scary mathematical achievements, we may want to talk about just the fact that he was the first to devise a method for the multiplication of matrices, expressing the Fibonacci numbers in a closed form, and also the Binet's theorem on the theory of conjugate axes and the moment of inertia of bodies. So happy birthday, Jacques Binet.
It's interesting, of course, that Baer became something of a shall I say antagonist to Tycho Brahe. It didn't seem that it was very difficult to become antagonistic towards Brahe. He managed to upset lots of people. So claim to fame for Tycho Brahe, apart from him being a terrific observational astronomer, is that he annoyed people piteously, which is really a shame.
Yeah, he was not known as a great collaborator. That's it doesn't say anything necessarily about Baer one way or the other, but Tycho Brahe did have quite the reputation.
Correct. In fact, I probably would have been more worried if Baer liked Tycho Brahe, because then it would have put him in the minority. So he picked his friends well, I would say, Baer.
Indeed, and it is quite interesting that they both used sort of very interesting forms of math. So, it's nice to think that we have a language of math to use now, but it's actually something that has evolved substantially over time.
Correct.
All right. Well, let's go ahead and remember where we are here. Actually, now that I'm looking at the time, let's just go ahead and remember that we are in fact broadcasting live from the Allan Carswell Observatory, and you all listening now are listening to York Universe. So thank you so much for joining us. We are broadcasting and located at York University in Toronto, Ontario, Canada. If you are interested to find out more about us, you can see our website at observatory.info.yorku.ca. And if you'd like to join along with the ongoing live OPV, you can see that very same website and click on Online Public Viewing, or OPV, which will take us to our YouTube channel, and you'll be able to follow along with the chit chat, live chit chat, and previously taken images, because it is in fact quite cloudy in Toronto tonight. If you do have any extra questions or would like to join us over on Twitter, that handle is at York Universe. And tonight you are listening to Elena, that's me, and we also have with us Satish and Paul. We are discussing astronomy and history. So let's go ahead and do a little bit more, I've been saying, spinning of the time wheel. So, we don't have a TARDIS, but we can use our minds.
More's the pity. More's the pity.
I know, it was best theme song intro.
Yes.
So catchy. I'm not even going to try to sing it, but
No,
I will go ahead and spin the dates a little bit. And I actually have two folks that I would like to remember today, just as this day in history. We did lose two people who were very important for astronomy history, and also a little bit of a tie-in with the upcoming Black History Month. So the first person I want to sort of put in a remembering column is Michael P. Anderson. He was born in December 25th, 1959, but he passed away February 1st, 2003, which I believe that day you will be hearing more about later.
Yes.
He was a U.S. Air Force officer and NASA astronaut who, along with 6 other crew members, passed away in the Space Shuttle Columbia disaster. He was the Columbia's payload commander and lieutenant officer in charge of science. He was posthumously awarded the Congressional Space Medal of Honor, which is really quite something. And he wasn't just any astronaut. He was a very significant astronaut, because he was actually one of the first Black American astronauts up in space. And it's really, it's quite a shame whenever you lose someone, but it was particularly significant. He was a very accomplished sort of technician, and he spent over 3,000 hours of flight time when NASA actually had selected him in 1994. So in order to get to be an astronaut, you have to beat out a lot of other people, a lot of very, very, very qualified other people, which he did. He was originally from the U.S. Actually, apparently came out of Spokane, Washington, which is not terribly far from where I myself originated. So I was like, oh, wow, so close yet so far. But in 1990, he got a Master's of Science from Creighton University in Omaha. He went up and joined the Air Force and got into, of course, NASA. He served as an aircraft commander, pilot, and of course did quite a lot of astronaut training. And he's also one of those people that I just feel like I haven't heard about enough. Michael Philip Anderson, really accomplished Lieutenant Colonel, Air Force, NASA individual, and of course was unfortunately part of the Space Shuttle Columbia disaster, which you will hear about more later. He was also on the Space Shuttle Endeavour, I believe, and was mission specialist on 8th Shuttle to Muir Space Station Stocking. So if you remember the Muir space station, that was the one that notoriously had the brown air problem at some point, but it was incredibly long-lived. It was really, people say things about Muir, but it lasted from 1986 all the way to 2001 and was operated by the Soviet Union and later by Russia. It's just absolutely incredible. And this fellow, he actually got to go up there and was really quite a fan of space. And he has a wonderful quote. Before launch, he actually told reporters, "There's always that unknown." And it sort of has lots of different meanings, but there are, he's gotten several awards, including as I say, the posthumous Congressional Space Medal of Honor. But he has some roads that have actually been named after him in Washington, in Cheney, Washington. There is State Route 904 that was renamed the Michael P. Anderson Highway, I believe it is. Which is, pretty interesting. So he also has a lunar crater, so taking it back to the moon. If you want to find the crater M. Anderson on your lunar charts and have a peek, I highly recommend it. So, it's just somebody that I think would be very good to remember here as we are approaching February 1st, which is tomorrow. That was the day that we lost him. But it's, not the only person, because I did want to make one other call out. Somebody who was born on February 4th, so taking it the other way around, 1969, and passed away in 2008, the amazing Beth Brown. She was a NASA astrophysicist who did a lot of outreach, and all of us who've done astronomy and science outreach can, identify with how hard that can be. She had a research focus on X-ray observations of elliptical galaxies and black holes, and she got a PhD in astronomy from the University of Michigan in 1998, the first African-American woman to ever do that. So she was really influential to so many people, and she did say, as I say, pass away far too early. But she did so much astronomy outreach. She had a lot of even apparently throughout junior high, she was participating in science fairs and really, really involved with, sort of science fiction, and then astronomy. So she got a bachelor's in astrophysics in 1991. She was involved with a lot of different research. She spent time up at Kitt Peak National Observatory, one of my favorite places to go for observing as well. I mean, after York Observatory, of course. But she was really quite accomplished, an amazing astronomer, amazing sort of outreach expert, and of course the first African-American woman to get a doctorate in astronomy from her department. So she once she had all that, of course, she went on to do a lot of really influential research. She was at NASA Goddard, National Academy of Sciences, and just doing all kinds of different work, in particular looking to help other women and girls in science, particular females of color. And she was a member of the National Society of Black Physicists. So as as she was doing all of these things, she unfortunately had a pulmonary embolism and sort of passed away quite young. So it's very fitting to kind of remember her and her outreach work here. As I say, as we go into February. So really influential people, and very sort of worth remembering, I suppose.
No shortage of talented people out there once you start looking, and it obviously doesn't matter whether we're talking about this century or the 18th century, thinking back to Benjamin. So many people contribute to the advancement of science, the advancement of outreach, and unfortunately, we just don't hear very much about them. Unless you start digging hard, they're nuggets, if you will, diamonds that are just not particularly evident.
Well, and that's exactly why we like to find them and talk about them on this
That's right.
show.
Yes.
And I
Yeah.
did find the Twitter hashtag for anyone who is interested in the ongoing Canadian Black Scientists Network's chat. It's BESTEMM, so BESTEM 2022. And that's I believe that is Black Canadian Black Scientists Conference. So there's all kinds of great stuff going on over on that hashtag, and of course on their conference. So very, very fun stuff. So let's see, before we get started on other news and what kind of interesting news articles we can get into, we do have a few reminders that we have to give everyone. It is somehow past the halfway mark on this show. Or we do have a few reminders about our Teletube Wednesday. So I just want to make sure everyone knows that every Wednesday we are actually broadcasting on our YouTube channel all kinds of interesting shows. We have live presentations, live viewing, and sometimes we have really, really interesting guest speakers. So this coming Wednesday, we actually have a very special Killarney Parks episode, which we're hoping to talk a little bit about the Killarney Provincial Park. And we have Jeremy Pawson, Sean Spencer, and Kathleen Shaler coming on to talk about what it means to have dark skies, how dark skies work at Killarney Provincial Park, and why we're so interested about this at the Allan Carswell Observatory. Of course, we're planning a little bit of an astronomy in residence program with them. So that is all happening this Wednesday, 7:30 p.m. on our YouTube channel. That's youtube.com/user Yorkview Observatory live. And so it will be live from 7:30 on Wednesday. Should be lots of fun. Highly recommended. All right. So that is most of the updates that are fit to print. Of course, you can also still buy our fabulous observatory calendars on our website. They are for 2022 and a pretty good deal, if I don't say so myself. I believe Paul here already has 3 of them, so that speaks to their quality.
Absolutely. One in every office that I exist in. Absolutely.
Excellent, excellent. Well, then let's go ahead and go through some astronomy news. So we do have a little bit of a mix of astronomy news articles. Let's go ahead and start with yours, Paul. It's a little bit of a astronomy recap for human spaceflight history, or I suppose it's not good times.
No, it's not. But it's important that we remember this period in the calendar, shall I say, between January 27th and February 1st, scattered over a number of years. The sacrifice that all sorts of individuals make. We've spoken a little bit about some of the astronauts already, but this particular memorial that I'm going to give is for 17 astronauts. It's not the only 17 astronauts that have given their lives in the pursuit of space exploration. There are at least 4 other Soviet astronauts who gave and paid the ultimate price. But from January 27th, 1967, through till February 1st, 2003, a total of 17 NASA astronauts lost their lives. So traditionally, this last week of January, NASA always commemorates the loss of these 3 crews. And so let me just sort of give the quick snapshot of how they lost their lives. The Apollo 1 mission, so this was back at the height of the space race. It was January 27th, 1967, and the first crew of the Apollo missions were literally practicing on the ground. They were in a simulator, a full-up dress rehearsal of the mission that they were about to fly, basically showing that the Apollo 1 atop the Saturn V rocket could launch that vehicle into orbit with the 3 crew, beginning the process of taking astronauts to the moon. Apollo 1 was never destined to go to the moon, but it was to show that the hardware as well as the crews were ready to embark on that journey to the moon, first to Earth orbit and then on to the moon. The 3 astronauts, Virgil Grissom, Ed White, Roger Chaffee, the first 2 were already legendary. They were part of the early crews, if you will, Grissom was, in fact, part of the Right Stuff, the original Mercury 7. Ed White was the first person who actually who walked in space. Grissom was the first U.S. astronaut to achieve the second U.S. astronaut to achieve suborbital flight after Alan Shepard, and Roger Chaffee was the new kid on the block, so as to speak. The three were in this full-up dress rehearsal when, unfortunately, fire broke out inside the capsule. The capsule was 100% full of oxygen. And so the short which had occurred, they traced it back to a short underneath one of the seats, basically caused the material within the capsule to burst into flames, and literally within 30 seconds the capsule was an inferno at something like 2,000 degrees Celsius. There was not a hope for the crew to get out, because at that point in time the escape mechanism, that is to say to be able to open the hatch, cycle the process and get out, was to take about 90 seconds. Needless to say, this was an absolute and unmitigated disaster. It resulted in, not surprisingly, a huge delay in the flights to the moon. It resulted in over 400 changes to the Apollo capsule. If you will, the loss of the three astronauts made every ensuing mission safer than they would have been otherwise. But the Apollo 1 crew lost to a fire on the ground in 1967. STS-51L was the flight of Challenger, and this was the space shuttle, of course. It launched on January 28th, 1986. 7 astronauts on board: Francis Scobie, Michael Smith, Ronald McNair, Ellison Onizuka, Judith Resnick, Gregory Jarvis, and Krista McCullough. The latter was, of course, the first teacher in space. So she was training as an astronaut. However, she was selected as a teacher in space. Challenger was lost 73 seconds into launch. It was a very cold, frigid day in Florida that day, and the O-rings on the solid rocket boosters that separated the actual segments of the solid rocket boosters, but compressed so that the very hot exhaust fuel from the solid rocket fuel could not escape through the joints, but rather would be expelled out the back end and give, of course, the appropriate thrust to the shuttle system. The cold had shrunk the O-rings, and hot fuel was escaping out through one of these joints. It weakened one of the struts holding the solid rocket booster to the external fuel tank. 73 seconds into flight, that strut gave way and the solid rocket booster cantilevered into the main fuel tank. Of course, it resulted in a catastrophic loss of the vehicle, and the 7 astronauts perished. Although, unfortunately, not immediately. There are indications that many of them survived that horrific mid-air explosion, but perished on impact with the Atlantic Ocean at an estimated 200 G force of impact. So 7 lost their lives with Challenger. And then STS-107 was the Space Shuttle Columbia. It was lost on February 1st, 2003, as it was approaching, was within 15 minutes of landing at the shuttle facilities at Cape Canaveral. During re-entry, the hot gases associated with re-entry entered the starboard wing of Columbia and eventually worked their way through to critical systems in the main body of the shuttle, and of course weakened the wing to the point where during the entry process, the wing basically disintegrated, and that caused a catastrophic loss of the vehicle. On this occasion, all 7 astronauts, in this case Rick Husband, William McCool, David Brown, Kalpana Chawla, Michael Anderson, mentioned him earlier, Laurel Clark, and Ilham Rahman, who was the Israeli astronaut, the first Israeli astronaut, all perished immediately. The shuttle had almost survived entry, but the reason that the gases were able to enter the wing is that a piece of external foam from the external fuel tank impacted the wing and basically shattered a section of it, unbeknownst to everybody, although there were suspicions already during ascent that there had been a problem, but unfortunately there was no way to see it. It was underneath the wing. The astronauts could not see it. There were no external spacewalks on this particular mission. It was a Space Lab mission, and that breach in the outer defenses, if you will, of the wing allowed the hot gases of re-entry to basically destroy the vehicle. So 17 astronauts, gave their lives in the pursuit of not just human spaceflight for NASA, but humanity in general. They all knew the risks. They were all willing to roll the dice. And in all instances, the vehicle retrofits that were made certainly led to safer space flight thereafter, although we certainly could argue that the loss of Columbia in 2003 was what prompted the US government to abandon the shuttle program in 2011. At any rate, a tip of the hat, we should all remember the 17 astronauts who gave their lives in these 3 missions.
And it is particularly significant, I suppose, that we have them all sort of colliding in this same time period of sort of end of January, beginning of February. So it is really, worthwhile remembering, as you say, this particular week or sort of general area of time is a good time to think about, just how difficult space travel really is, and the people who have really given their very best to break that new horizon and to help us, go out there and explore a truly unimaginably unhospitable environment. And I think it's there's always that unknown is kind of a good quote in here, because it's with this kind of activity you really do never have any guarantee. I have to say, all things considered, I am very, very glad that William Shatner did make it back.
Yes.
Blue Origin.
Yes.
Blue Origin, yes, there is some good news. At least the more recent ones, we have avoided any of these kinds of accidents. So hopefully that pattern does continue.
Correct.
All right, so I'm not sure that we really have time for a whole nother article.
Oh, I think Satish's article we can sneak in.
Can we sneak in your article, Satish?
I can try.
I mean, meerkats are pretty cool, so.
Give it a whirl, mate. Give it a whirl.
Try and speak without the drama. So this is a radio telescope, 64 antennas spread over 5 miles. That's just to give you the picture. And we have been presented images after 3 years of researchers processing over 70 terabytes of data. And the focus was right at the central regions of our own galaxy, which is also known as the Milky Way. And then it's a panoramic view of the Milky Way's center, spread over 1,000 light years wide and 600 light years high or thick. So that's basically a galaxy's disk, home to most of the stars and exoplanets. And in the image, if you do go online and see that, it can be seen as a ragged horizontal streak with a dense blob right in the middle of it. And the blob is the black hole lurking in the background, which is probably 4 million times as massive as our sun. And then the rest of the image surrounding this, those are actual glowing filaments, which cosmologists have been talking about, which are spread over 100 million light years. And they're basically magnetized tubes of gas and high energy particles, which sort of connect everything in a manner of speaking. And then the images are particularly important and obviously make a lot more sense as opposed to the usual we have had till now, is because they are in the radio band of the electromagnetic spectrum. And that basically means the invisible part of the spectrum. And in terms of astronomy, they are actually the fine-tooth comb version of observations, because when you're dealing with loads of cosmic dust, it is the radio waves which actually give you the better, brighter, probably picture. And
all right,
for more,
Satish, I think we're going to have to go with better, brighter picture and tell everyone to please look for the Meerkat Galactic Center Mosaic. Meerkat Galactic Center Mosaic. I think that is where we'll have to end off today, because I'm getting the message that we do, in fact, have to stop the episode. So we'll maybe talk about that again a little more next time. But Meerkat Galactic Center, look it up. It's amazing. So thanks, everyone. You are listening to York Universe, broadcasting live from Allan I. Carswell Observatory in Toronto, Ontario, Canada. We're wrapping it up rather quickly tonight because we are out of time. But you can always find us on Twitter at York Universe or see our website at observatory.info.use.ca. This has been Elena, Satish, and Paul, very quickly wrapping up all kinds of time travel topics. So thanks